Hello, good day to you. So what you've got in front of you is an ant swarm optimizer, which is based on the idea of following how ants discover food in nature, and is used in computer science for finding the shortest path and the critical path for between, say, servers or other data science problems. If you want to see them at the beginning, they behave much more like particles. You can see they just randomly roll around, and then one of them will hit the food. And once one's hit the food, it lays pheromones along the entire path that it's gone down, which means that every single ant within the swarm is more likely to pick sites or locations where another ant's gone down and successfully found food. So over time, this builds up a map of the area that optimizes the ants to go down a specific location. These particular ants have got a few features to try and limit them wasting their time going back and forth on themselves. They do have a boredom feature to count how many times they've revisited a single location, and they devalue the value of the percentage chance of them that they'd revisit an old location every time they visited it. They've also got some evaporation going on, so the pheromones are removed over time, which means that they're more likely to branch out and try new paths and find new optimized paths. If I move the leaf around, you'll see that they don't actually de-optimize and go back to searching very quickly. It can take actually quite some time. So that's a problem with the ant swarm optimizer, in that it learns a model of how to deal with the situation, and then it's not great for reverting to the previous search behavior very quickly. I kind of like it. I like the idea of using it for critical path analysis. I particularly like the idea because I have a sort of sneaking suspicion I'd like using it for finding the critical path in projects and the like, having a bunch of data about events and looking to see how those events all link together might be one use for this swarm. The code didn't take me a huge amount of time to write, though. I found it really frustrating getting it to work, as in it took me the normal 30 minutes to plonk down 3 classes, write some functions for those 3 classes to deal with how they behave with each other, but it took me a lot longer to sort of try different ideas out with it and see what happened if I move food and things like that. And I think this is really important for me because I've got to work on doing a bit of a spaceship game where, because it's got gravity involved, I don't really know how to do the pathfinding in it, because I'm not going to run through the entire galaxy and calculate the gravity effects on every single point. But this seems to work for what it was, and I quite liked it, was quite impressed with it. Thanks, have a good day, good night, bye.